So, last lecture, we ended with the idea of what is the plan for the course. So we talked about that. So now we're going to start basically chapter 1 of the book, background information. Okay. One of the things we want to talk about here is the scientific method. How do scientists study things? So we start off with an observation and we say, I see something and I want to explain that. And so we'll start off with a hypothesis. This is basically a scientific guess. It's not just a wild guess. It has to be based on existing science, existing principles. We don't just make up something. We say, hey, based on what we know about how things work, I think that because of this. Okay. And then we test it in some fashion. In a laboratory, then you would test it, here with an experiment. For astronomy, you observe. You say, hey, I think that what I'm seeing is how a star forms. So you look at other places where it looks like stars are forming and see that same sort of thing happens. Okay. Now, after you've done many, many tests or experiments or observations, then you start creating a mathematical model as to how all this works. Now, if your model then in order for it to be truly scientific, it has to be predictive. In other words, it says, okay, so my model describes this, therefore, it means this other sort of thing should happen. So according to my model, that if this is how stars form, there has to be outflow of gas from where stars are forming. So you go look for that outflow of gas. This is more observation. So this is a feedback. So your hypothesis leads to an observation or a test, which leads to a model, which then is tested again. Now, after it has survived many, many, many tests, we call it a theory. A theory is really a set of models and mathematical analysis and mathematical descriptions. It's not, the layman's term theory is pretty much the same as hypothesis. I have a theory this happened. No, for scientists, hypothesis is your idea about what might be happening, and the theory down here is what has survived all the tests. So this would be like theory of gravity. It doesn't mean I think there's gravity. Theory of gravity is the mathematical analysis of how gravity works and how you can calculate what's going to. Okay. Scientific hypothesis, there's several different ideas here. Empirical is based on observation or experience. Hey, I noticed the sun rises in the east and sets in the west. I wonder why that works. Okay. Deductive. We've already got theoretical work, and so we say, well, based on our basic theory of how things work, I believe that such and such. So based on my understanding of how the Earth rotates, I think if I change latitude, the sky should look different. Then what you do is you go check. Okay, all these things have to be testable in some fashion. And all of it has to fit with previous work. You don't just go out on a limb and say, hey, I got something that's different from everybody else. What you do is you base it on what came before, because the science that came before explains something. It may not have been complete, it may not have been accurate, but at least it kind of explains. So what you come up with has to be consistent with what you were trying to explain before. The SI units, kilograms, meters, kilometers, and so forth. All of these things that we generically call metric units have associated with them these prefixes. Kilo means 1,000 or 10 to the 3. Mega means times 10 to the 6. Giga is times 10 to the 9. Micro is 10 to the minus 6, and nano is 10 to the minus 9. So we say that something is 45 nanometers, then we could write it 0.0000000045, or we can write 45 times 10 to the minus 9. That's way easier, so that's why we use scientific notation. Okay, one of the labs that I've already posted is one you can get started as soon as you have a clear night, and that is the star count lab. And basically, you just go out and count stars. That's it. You just go count stars. Go someplace where you can see the sky and count every star that you see in the sky. Now, in theory, there's about depending on who you ask, 6,000 naked eye visible stars. Some people put that number close to 5,000. Some people put the closer number to 8,000. It's really hard to say what's the dimmest you can see with the naked eye, because different people see different dimness things. So, question. If you go out at night, you can see 6,000 stars. The answer is no. Why not? Well, think about it. Why would you not see 6,000 stars? Well, there's several reasons. One, you don't see the entire sky. You just see what's over your head. People in different parts of the world see different things in the sky. And so you can't see the entire sky any one night. And so that's going to be one issue. The other issue is this picture you see right here was taken in a really dark place. You're not likely to be in that dark of a place. The brighter the lights are around you, the less that you see. And so those factors really affect what you're able to see. Okay, so constellations. One of the things that we learn here when we start looking into the sky are constellations. And I'm going to post a map for you that gives you a map of the sky. We can go out and start looking, and it marks constellations. Now, what do we have here? Well, what we have here, this constellation right here is Orion. Most people recognize it because these three stars right here make up the belt of Orion. These are his shoulders. Here's his feet. His head's up here. He's got a sword hanging down from the belt. Okay. And so that's the constellation Orion. In the ancient world, they looked up at the sky and they saw a lot of patterns in the sky. And they tried to make sense of it. Humans try to make patterns out of just random stuff. You look at a cloud and you say that, hey, that cloud looks like a sports car. Okay, no, that cloud over there looks like a mountain. That cloud over there looks like a castle. Hey, that cloud over there looks like a dragon or a frog or what have you. Okay, and so you try to make, well, no, they don't look like, they look like clouds. Okay, but your brain tries to put a pattern to this. Now, everybody looks up and sees something different. We think of this group of stars as Orion because the Greeks look in the sky and they saw a hunter right here. Other people have seen different things. For example, in Central America and Mesoamerica, this right here was a cooking hearth. This was a cooking hearth right here with a loaf of bread on it, and the cook was standing right there between the two. Okay. And so here we have different cultures looked up and saw different things. The group of stars that we look at and we see as the Big Dipper in Central America, that was a jaguar. And so everybody sees it differently. They had stories that go with these things. So these were tied to mythology. And so that was another sort of thing that ties in here. So we have stories and mythology. Different star atlases try to draw these things, but everybody drew it differently. Not everybody showed Orion looking like this. Okay. But over time, they got to realizing that this was a little more complicated, because you'd sometimes find stars down here between one constellation and the other. It's like, well, where does one constellation end and the next one begin? Because everybody drew these things different. The drawing is totally unofficial. Even the way you connect the dots here is totally unofficial. Everybody does it differently. So what happened was, in the early part of the 20th century, about almost 100 years ago, the International Astronomical Union got together and they divided up the entire sky into 88 segments. And they just drew boundaries in the sky. And the constellation is no longer defined by the stars, no longer defined by the picture, but by the boundary. The boundaries typically covered the old constellations. They sometimes drew the boundary, like weird, so that it cut off like part of one constellation and made it part of another or what have you. But this is kind of how they define. Okay. So this was in 1929, okay, 1930, 90 years ago, so almost a century ago. They published the list of 88 official constellations. Now, in the 88 list, 66 of them go back to constellations the Romans used. And the Romans borrowed almost all their constellations from the Greeks. 18 of the Roman constellations go all the way back to the Mesopotamians. So there's this continuity of constellations here, at least in Western society. Okay, again, other societies looked up and saw different things. But in the Western society, then this is what we have. Okay, this is the official group right here, 88 constellations. The IAU, the International Astronomical Union, this is international, all astronomers all over the world are part of this. And they're really the only ones that officially can name anything. And so they have defined 88 constellations in the sky.